acid accumulator. 2. It is used in a dryer, or it is used as a dryer in paints. Lead 4 oxide. Lead 4 oxide is another oxide of lead, but this time around a higher oxide. Preparation. It is made by treating di-lead 2 lead 4 oxide with triazonitrate 5. When this is reacted with triazonitrate 5, we have the production of lead 4 oxide. Physical properties. It is a dark brown solid which is insoluble in water. Chemical properties. It dissolves in alkali to form plumbate 4 salts. 2. It is a powerful oxidizing agent, giving off oxygen on heating alone. It's a powerful oxidizing agent which give lead and oxygen when it oxidizes concentrated hydrochloric acid to chlorine. It oxidizes hydrochloric acid to chlorine. That means when it's reacting with hydrochloric acid, here you have the lead chloride. It gives you lead chloride and also chlorine. So here this one succeeds, this compound of interest succeeds in oxidizing the hydrochloric acid to chlorine. So that is one of the chemical properties of lead 4 oxide. 4. It combines with sulfur 4 oxide to give lead sulfate. It combines with sulfur 4 oxide to give lead sulfate. Lead 2, lead 4 oxide is another important oxide of lead. It is also known as red lead oxide. Preparation. It is prepared by heating powdered lead 2 oxide in air at 400 degrees Celsius. Lead 2, lead 4 oxide. It is also known as red lead oxide. Preparation. It is prepared by heating powdered lead 2 oxide in air at 400 degrees Celsius. PbO, 6 of it plus oxygen to give Pb3 plus P3O4. So this is what is known as lead 2, lead 4 oxide, which is also known as red lead oxide. Is an important oxide of lead. Physical properties. It is insoluble in water. Chemical properties. It behaves as a mixed oxide. It also reacts with dilute triazonitrate 5 acid. How it behaves as a mixed oxide is simply this. So here it's behaving as lead 2 oxide, here it's behaving as lead 4 oxide. That is why it is also known as lead 2, lead 4 oxide. Uses. It is used in making glass, which is lead glass, plumber's cement, and priming paints. Lead 2 hydroxide. Preparation. It is formed when an alkali is added to lead 2 salts. when you have an alkali, lead 2 salts, and you now have an alkali, which is sodium hydroxide, being added. So here you have lead hydroxide, which is the compound of interest alongside with. This is how lead 2 hydroxide can be formed or prepared. Chemical properties. It is amphoteric by reacting with acid and alkali to form lead nitrate and tetrahydroxoplumbate 4 respectively. Lead 2 chloride. This is another important compound of lead. Preparation. It is prepared by double decomposition reaction between a soluble lead 2 salts and sodium salts. This is lead nitrate and this is sodium chloride. Double decomposition means these combine with this, while this combine with this, and here you have lead chloride plus sodium nitrate. So this is the compound of interest, which is lead 2 chloride being formed in the process. Properties. It is insoluble in cold water and fairly soluble in hot water. The characteristic of lead 2 chloride is that in cold water it is insoluble, just like other chloride. But when the water is heated, it becomes fairly soluble. It reacts with concentrated hydrochloric acid to give tetrachloroplumbate 2 ions. Lead 4 chloride. This is a higher chloride of lead 2 chloride. Preparation. It is prepared when concentrated hydrochloric acid reacts with lead 4 oxide. Concentrated hydrochloric acid reacts with lead 4 oxide to give lead 4 chloride plus water. So this is the compound of interest, which is lead 4 chloride. Properties. It is a yellow covalent liquid. At temperature greater than above, it decomposes to give lead 2 chloride and chlorine gas. Lead 4 chloride at a temperature greater than 0 degrees Celsius, which is above temperature, it decomposes to lead 2 chloride plus chlorine gas. Lead 2 triazonitrate 5. Preparation. It is prepared by reacting lead 2 oxide with dilute triazonitrate 5 acid. Lead 2 oxide with dilute trioxonitrate 5 acid. Here 2 moles of this react with this to give lead 2 triazonitrate 5 and water in the process. So this is one way by which lead 2 triazonitrate 5 salt can be prepared. Properties. It is a white crystalline solid which contains no water of crystallization. It should be noted that the compound, one of the compounds of lead that does not contain water of crystallization is lead 2 triazonitrate 5 salts. On heating, it decrepitates and decomposes. When it is heated, it decrepitates to these 3 entities. So this is what you have. You have lead oxide, lead 2 oxide, nitrogen 4 oxide, and oxygen. So that is what is meant by when it decomposes or decrepitates. That means it's very unstable, which when heated it gives the following byproducts. Transition metals. What are transition metals? They are metals with partially filled d orbitals. However, with exception to copper and zinc, which have their d orbitals fully filled. Therefore, they are called pseudo transition metals. Physical properties of transition metals. 1. They have high melting and boiling points. 2. They are hard in nature. 3. They are dense and lustrous. 4. They are good conductors of heat and electricity. Chemical properties of transition metals. 1. They are moderately reactive. 2. They have variable oxidation state, just like in the case of copper. Copper has +1 state, +2 states. So that is what is meant by variable oxidation states. They form complex ion. Complex ion of copper is simply this 2+. This is a complex ion. So the metal that is in interplay here is copper, which is also a transition metal. They exhibit catalytic activity, just like in the case of potassium triacylchlorate 5 salt, which require copper oxide, which is copper oxide as a catalyst to give the corresponding potassium chloride.